Happy Wednesday, biologists. Today is Wednesday, April 29th, 2020. We are going to continue working on our family tree for our QPA for Unit 5. So today we are working on the same standard. So we're going to be describing how DNA is passed down by tracing a trait down familial lines. Here's my contact information. Make sure that you are contacting me. Please reach out. I like to hear from you guys. And if you have any questions, please do not hesitate to email me. And I am going to have us pause our video right now to make sure that we have our QPA pulled up from Google Classroom. And if we're working on it, if we prefer to be drawing / writing this stuff, either on a separate piece of paper or the printed out QPA, to pause, make sure you get that and grab a pencil as well. Okay, welcome back. So you should have grabbed your QPA or have it pulled up on your laptop. Make sure you have a pencil, writing utensil. So I'm gonna go to my QPA over here. So last time we should have created something that looks similar to this. So some sort of familial tree. So it can be your own family tree or a family tree of someone else of your choosing, or Beyonce, Jay-Z, if you'd like. And so now we're going to be focusing on specific traits that we're going to pass down, that we're going to kind of trace down these family trees to see where the children are getting their traits from. So a list of possible traits you can choose. You need to make sure you're choosing at least 2 of these. Choose as many as your heart desires, but at least 2. Can't be less than 2. So here are some examples. We can do eye color, blood color, heart disease, high cholesterol, color blindness, etc. So you can choose one of these, or if you really say, hey, in my family, I noticed that we all have X trait, and it's not one of these, that's fine. You just got to make sure you are following the phenotype down the family tree. So remember, phenotype meaning the physical characteristic, and then the genotype, which is the genetic code for it. So we obviously can't be sure of everybody's genotype in this specific scenario unless we were able to access their chromosome. So you're just kind of speculating on what potential genotype they could have. So you can do that here. So if you already wrote out your family tree here, you can just add it onto the same page, or you can do it on this separate page if you'd like, whichever is easiest for you guys, whatever makes sense for you. So for example, you can say, hey, in the maternal grandmother, we see that she has blonde hair or blue eyes. She has blue eyes. So that means from her parents, let's say we also know that dad has brown eyes and mom has brown eyes, but kid has blue eyes. So what could the potential genotypes of this be? So I'm going to share. I'm going to start writing. Let me just find my writing utensil. So let's say that my grandma has blue eyes, but both of her parents have brown eyes. I'm just gonna write brown and brown because it's actually kind of awful, my handwriting. Okay, so my grandma on my mom's side has blue eyes, but let's say, for argument's sake, that both of her parents have brown eyes. So what could the potential genotypes of each of these individuals, of my grandma and then her parents, be if this is the phenotype that we're seeing? So because we talked about blue eyes being a recessive trait, and that should make sense, there's seemingly less people on the earth, right, with blue eyes. So my grandma necessarily, since that's a recessive trait, would have double small b, double small b. And if brown eyes is the dominant trait, then by contrast, they would have the dominant, at least one of the dominant alleles. But hey, we can't say, oh, they both would be homozygous dominant, because my grandma over here has double recessive. She's homozygous recessive for this trait. So she necessarily needs to get one copy of the recessive allele, this lowercase b, from both of her parents. So both of her parents, even though they have brown eyes, they necessarily would have to be heterozygous dominant, meaning that they have one copy of the dominant allele, this uppercase B for brown, and then one copy of this lowercase b. So they would still exhibit the brown trait because this would be normal dominance, complete dominance. So they would have brown eyes, but since they're both giving this small lowercase b to my grandma, it would be blue eyes. Which is really, they only have a quarter chance, obviously assuming we're really simplifying how traits are passed down. But this is a good way to think about it, to kind of conceptualize it. So you are doing this for everyone. So if you want to stick with the blue eyes or with the blue eye color stick, go ahead and do that. Just make sure you're thinking about what color eyes are dominant versus recessive. Same thing with blood type. So we did different resources back on that. So, and if you get stuck, if you're saying, hey, Ms. Fabrizio, I don't know how to conceptualize this, if you want to do heart disease, if that's something that's more common in your family, or color blindness, then I can definitely talk you through it. So just shoot me an email, a text, call me, and we can talk about it. So it should look something like this. I don't care what specific letters you're using, as long as it makes sense, and it makes sense, you're consistent with what letters you're using, and then you're using the correct uppercase versus lowercase. So we should be all set then. So you guys should be completing the part 2. So explaining what potential what phenotypes you see in your family tree that you created for each individual. So 2 of those, 2 different traits, and then the potential genotypes for each of those traits. Okay, I'm going to get rid of the writing now. And, oh, I just stopped the video. Okay, I'll get me back up in a second. So I'll just quickly end the video. So if you guys have any questions, as always, make sure you're commenting, emailing, texting me. Here's my contact information. Please reach out. Okay, so see you guys.